we are going to go ahead and look at the distance formula. We're going to start with practicing some Pythagorean theorem. So using Pythagorean theorem will help us in order, to do all of this work. So we're going to start with A. And remember, Pythagorean theorem is a squared plus b squared equals c squared. Remember, c stands for the hypotenuse across from 90 degrees. So for A, it's going to be 5 squared plus 12 squared equals x squared. So you can just simply put that in your calculator. Desmos is a great place to do that. So we get 169 equals x squared. Then we just take the square root of both sides. And we're going to get 13. Okay, so for this next one, 5 is my hypotenuse. So I'm going to go x squared plus 4 squared equals 5 squared. So I get x squared plus 16 equals 25. Subtract 16 from both sides. X squared equals 9. Square root of both sides. I know this is fast, but this should be pretty similar to what you guys have done before. We get 3. Okay, so pretty simple. We're going to talk about the distance formula is almost like the Pythagorean theorem, except we're going to make it the square root of a squared plus b squared equals c. So we're just going to stop like that. So we're going to do the same thing we've done before. Again, it says ruler. I'm just going to use this little notepad to do it. First, I'm going to plot the points. 1, 2, up, 1, 2, 3, making sure you do x first and then y. I'm going to go over 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm just going to connect them. I'm just using my pad of paper right here. Again, phone, computer, whatever. All right, and then we're going to draw in our slope formula. Okay, we want to find the distance of this length right here. So I went up 1, 2, 3, 4, 5, 6. And I went over 1, 2, 3, 4. Okay, so that's my distance. So we're just going 6 squared plus 4 squared and the square root of that. So we're just putting that in our calculator. You can do it in pieces like this. 6 times 6 is 36. 4 times 4 is 16. Then we can add 36 and 16 together. That equals the square root of 52. And then we can find the square root of 52 is approximately 7.2. Okay, so this is one way to do it. This is the graphic way. You can completely ignore the graph and do it this way, where this is x1, y1, x2, y2, and we can use this formula, y2 minus y1 squared plus x2 minus x1 squared. And again, you could have switched the, move the x's first and the y second because it's an addition, but this is fine this way. So we're going to go the square root of -7 minus a -3 squared plus -8 minus a -2 squared. Remember, a negative and a negative makes a positive. And then we're going to get what we need. -7 plus 3 is 4 squared. -8 plus 2 is -6. But they're squared. Remember, the negatives don't matter when they're squared. So we're going to get the square root of 16 plus 36, which is the square root of 52, which gives us 7.2. Okay? So again, either way is just fine. You can use the graphic way or the equation way. So let's try one more of each. So I'm going to do the graphic way for this one. I'm going to go -2, 1, 2, up 6, 1, 2, 3, 4, 5, 6. I'm going to go +3, 1, 2, 3, down 5. 1, 2, 3, 4, 5. I'm going to connect them. Okay. Now I'm going down 11 over 1, 2, 3, 4, 5. Okay, so that's just 11 squared plus 5 squared square rooted. So we get the square root of 121 plus 25, and 121 plus 25 is 146. And then if we find the square root of 146, we get 12.08. Okay. All right, let's do one where we're just going to use the formula. Again, that formula is the square root of y2 minus y1 squared plus x2 minus x1 squared. So this is x1, y1, x2, y2. And so I'm going to go -2 minus 8 squared plus 10 minus 3 squared. -2 minus 8 is 10, -10 squared. 10 minus 3 is 7, so we have 7 squared. So we get 100 plus 49, so we get 149. And we just need to find, the square root of 149. And we get 12.2, approximately. Okay, so those are two different ways to find the distance formula.